electrical menu, click the downward triangle under symbol table and choose signal adapter. Set and convert the signals for both conveyors. Select conveyor 1, click Add parameter. Then select conveyor 2 and add a parameter. Check both and modify the alias. These are physics object parameters. Use a single signal to control them. With the data type as bool. We need to perform a formula conversion to convert the bool signal and the double signal. Click conveyor 1, then insert conditional. If the conveyor signal is received, and it is true, set the speed value to 200, otherwise 0. Using the same method, set conveyor 2. When it is true, set it to 200, otherwise 0. This setup enables the signal to control both conveyor 1 and conveyor 2 simultaneously. After completing the setup, click Sequence Editor to enter the simulation sequence for logic control settings. Right-click on Sequence Editor to select the Float tab and drag it below. In the blank area, right-click to add a simulation sequence. The first step is to start the conveyor. Set the signal we configured to true. At this point, the speed of the conveyor, as per the transformed formula, will be 200 when it is true. Click OK. Click Play. It works. Double-click the conveyor transport surface and go to the Runtime Inspector to check the speed of the conveyor, which is 200. The conveyor stops because it is blocked by the blocking cylinder. The next step is to stop the conveyor. Right-click to add a simulation sequence. Select the same signal and set it to false. Note, when the first sensor triggers, set it to false. Click OK. Click Play. Observe in the Runtime Inspector. When it stops, the value is 0. Let's move on to RFID data collection. Since it cannot be simulated, we'll let it pause for 2 seconds for the RFID data collection. Do not select any objects. Connect the previous and next signals by clicking and dragging with the mouse. After completing the collection, the blocking cylinder should retract to the on position, which means making it move. Set the position for the blocking cylinder 1 to 30 and click OK. Observe the effect. It's retracting. Let's proceed. Once the blocking cylinder 1 retracts into position, the conveyor belt starts. Set the signal to true. When the conveyor runs to this position, make the engraving workstation stop. Next, we add a condition for the conveyor to stop. It will stop again when the second sensor triggers. Click OK. Click Play and observe in the Runtime Inspector. It stops correctly. Add the ejecting cylinder. Its position to elevate by 50 mm. Click OK. After the ejecting cylinder rises into position, allow 2 seconds for laser engraving. Don't select any objects. Connect the sequence. Once engraving is complete, the ejecting cylinder retracts to its original position. Next, retract the blocking cylinder too. Its initial position is 0, so set it to move down to 30. Activate the blocking cylinder, and once retracted, the conveyor will restart. Set the signal to true. Click OK. Connect the sequence. Click Play and observe the effect. The timing might be quick at this point. Adjust the engraving time to 2 seconds. Test again. The object has changed. Now, set up an object sync to generate a material source. In the mechanical menu, select Object Sync from the drop-down list under Rigid Body. Select the third sensor to collect material at this point. In the simulation sequence, right-click to add a material source. Select the object source, check Active, and click OK. The material source will generate immediately. After the conveyor starts, generate the material source. Observe the effect. Notice blocking cylinders 1 and 2 are in the on state. Conduct a reset. Right-click to add a simulation sequence. Set the blocking cylinder 1 to its original position. So it will be reset when the second conveyor starts. Wait 2 seconds to reset the blocking cylinder tool. Observe the effect. First, open the laser marking unit case model. Today, we learned the basic setup methods for the laser marking unit case model and mastered techniques for setting up rigid bodies, collision bodies, sensors, and actuators. I hope you can apply what we have learned to your practical work and contribute to the development of the manufacturing industry. Finally, please complete the following exercises and practice more in your spare time. This lesson ends here. See you next time.